For this demo, I will use my AWS account. If you do not have one, you can always create a free tier AWS account, and at the time of recording, it provides up to $200 in credit that you can use for up to 6 months. We are in the management console, and as a first step, we will go to Amazon Bedrock. You can see it is listed amongst the recently visited pages, but you can also search for it in the search bar. Amazon Bedrock is a fully managed service that provides various capabilities for building generative AI solutions. In the left navigation window, you can see the various features of Amazon Bedrock. We are interested in the prompt management, which is under build. The way this works is that we will create a prompt, use a sample input to test our prompt, and then optimize it till we are happy with the generated output, after which we can create a version and use it in our code. So let us create our prompt. By default, all prompts are encrypted at rest using an AWS managed encryption key. I will keep the default settings. We are here in the prompt builder window, and this text box is where we will define our prompt. We can define variables enclosed in curly braces, such as this variable called topic. So as a first step, I will write my prompt. Here I have written my prompt. I have instructions for solving the math problem, 3 examples of what good looks like with problems and their solutions, and I also have a variable called math problem that I will substitute with the actual math problem that I want to solve at runtime. In order to test this prompt, I have a sample input. I can set the value of the variable for testing the prompt. And as a next step, I have to select a model that I will use to run this prompt against. I will use Nova Lite because this is a very simple prompt. There are some inference parameters that I can set. I can define the maximum output token length. I can also define stop sequences, which is basically the last token in the output, after which the model will stop generating any further tokens. This can be beneficial when you have structured outputs and you know what the last token would be. For example, a closing tag of the XML body, etc. You can also control the randomness and creativity of your response by setting parameters such as temperature and top P. They take a value between 0 to 1, 1 being most creative and 0 being least creative or most deterministic. Then there are some additional settings, such as if your model supports more parameters, you can define the additional parameters under the additional model request fields. You can also specify tools that your model can call on your behalf to generate the output. You can also cache static content of your prompt within the body of the model itself, so that when you make the invocation call, you don't have to send the portion of the prompt anymore. This not only saves you cost because you have lesser number of input tokens, it also helps you speed up your inference. This feature is supported by only a select models such as Anthropic. So now that we have our prompt defined, we have our test input, and we have also chosen our model and defined our inference parameters, the next step is to test our prompt. If you're happy with the output that has been generated, you can create a version of this prompt and start using it in the code. If you're not satisfied with the output of your test run, then you can further update the prompt either manually or using this optimize feature within the prompt management. This feature sends the input to a large language model, which understands the intent by reading your prompt and then tries to optimize it. So let us try this feature. The model has rewritten the prompt and it has basically organized the prompt under different sections with proper headings. It has also expanded the instructions for solving the math problem. I can test this prompt just like I tested the original prompt by selecting the model and entering the sample input value. The output is also different than the original prompt's output. If you like this output, which is slightly more detailed, you can keep this version of the prompt by replacing it with the original prompt. However, in this case, I will exit the comparison and keep the original prompt. So I've created a version of the prompt. And if you come in the main window of the prompt, you will see that a new version has been created. Every prompt version that we create has a unique ARN, which is the unique ID for this prompt, and we will use it in our code when we make the call to the model. The prompt version itself consists of the actual prompt text that you created, the model that you chose, and the inference parameters that you selected. All of this is bundled together in this version. So let us test this prompt version. Lambda is the serverless compute in AWS, and I have already created a function called math problem using Python runtime. Before we look at the code for this function, let us look at its configuration. I have created an environment variable for holding the ARN for the prompt version. Besides setting this environment variable, there is another thing I have done. So I have assigned a role called Lambda Bedrock Converse role. And if we see the role itself, you will see that I have assigned a trust relationship so that Lambda can assume this role. And its policy has permissions to invoke Bedrock APIs. So going back to our code, I've used Boto 3, which is the Python SDK for interacting with AWS services programmatically. I've used it to create a Bedrock runtime client that we will use to interact with Bedrock service. I've assigned the prompt ARN to a local variable, And I have also assigned the user input, which is the math problem that we want our model to solve. I'm using Bedrock Runtime's Converse API to invoke the model, and I have set up its two parameters. One is the model ID, which will be the prompt ARN. Remember, prompt ARN contains the prompt text and the model that we have chosen and the inference parameters. In the prompt variables, we will assign the value for math_problem variable that we have defined in our prompt. We will assign it to the user input. So let us deploy this code and test it. So as you can see, the code was able to retrieve the prompt version that we had created in the prompt management service and use it to invoke the model and generate the output for us. It is important to note that whatever we did using the user interface today in the management console is also available using APIs, and you can do this programmatically in your code. In fact, it is recommended that you maintain your prompts and your prompt variants as part of your code so that you can integrate it with your CI/CD pipelines.